So the Calypso mission was a mission that we studied during the decadal. So this wasn't pre-decadal. This was a New Frontiers concept. There was a lot of New Frontiers concepts that were studied during the construction of the decadal survey. For those who have never been part of that process. And uniquely, Calypso was a study that we collaborated on between two different panels. So I was on the Ocean World and Dwarf Planets panel, and Bill Botke, who is my science co-lead, was on the Small Bodies panel. Essentially, it's kind of like having two PIs on one mission. As I describe this concept, you'll understand why. And so I definitely want to acknowledge the work that Bill did to help me put this presentation together. But essentially, I'm showing you not a very modified version of the slides that we gave to the steering committee when we pitched this concept to them after it was costed. And hopefully you will see the parallels between this concept and all of the other talks that we've had so far this afternoon. Because a New Frontiers concept has to be tight in order to fit into a box, I'm going to talk about the science that we were pitching, which does not necessarily mean that we would exclude any additional awesome science that would come from something like this, but we were really focused on using Calypso to determine the limits on and the pathways to ocean world formation in two completely different contexts, hence why we had two science leads. I was leading the ocean world sort of satellite component, and we were proposing to do a flyby of the Uranian moon Ariel. And then we would do a KBO flyby of Gungundima and its companion Greku. And this is important to say in that these two flybys were part of the primary mission. The Greku and the Gungundima flyby was not an extended mission. It was all meant to fit in one box. This was a long science team. Please go look up the report that we wrote. But I also want to take a few moments to acknowledge that when we do these mission studies, they are generally standing on many shoulders. And Candy Hansen was a big advocate for this mission concept, and she pitched it to the panel as something that we should study based off of a New Frontiers 4 proposal that was developed at JBL called Argo, which did something very similar, but it was a flyby of Neptune and Triton with a scientifically selected KBO. So rather than doing something opportunistically, it was selected and designed as part of the concept. It was never formally proposed because of a plutonium shortage, which sounds familiar, and I highly recommend that you go look up that study because I think it was really interesting. Following that, we had the Unified Dual Mission Decadal Strategy for exploring Uranus, Neptune, Triton, dwarf planets, and small KBOs and centaurs, which is also a really interesting report that I recommend you go look up. And the other thing I want to say is that while I co-led the Calypso study with Bill, Candy Hansen was the science lead for the Ocean World Surveyor, which was also ended up being selected for New Frontiers 7. And this was a New Frontiers class orbiter that focuses on the Neptune system. And I think it's important to note that when we talked about designing Calypso and the Ocean World Surveyor, the point was to understand that both of these missions could close at either Uranus or Neptune. And I think that's a really interesting aspect here that we don't spend a lot of time talking about. Okay, now I have even less time to talk about the rest of this really cool stuff. So there's a lot of really compelling science you can do, even though it's on New Frontiers. But as I said before, because it's New Frontiers, you have to be a little bit more constrained on the science that you're proposing. We're really focused on limits of ocean worlds revealed in both ice giant systems and in the Kuiper Belt. But we're doing flybys of each one of those, so naturally that's going to be limiting. But as we have been hearing all week, flybys are incredibly productive mission architectures. There's also uranium science that can be done, including rings and additional moons, magnetospheres, all that kind of stuff. And certainly KBOs are a really important part of understanding planetary systems, how they're born, how they evolve. And Calypso really addressed a lot of different decadal survey questions. And as you can imagine, when you're working on a study that you're trying to appeal to the decadal steering committee, you certainly want to prove that your mission concept can achieve decadal level science and a lot of decadal level science. And so if you want to know, in the backup slides here, I have a little bit of a trace to show you all the different questions that we can address. Calypso uses a single RTG, which includes a pretty significant margin. And it was really important to us to make sure that this mission fit within 20 years or less. And so it's a total 18-year mission, which we thought was really impressive if we do say so ourselves, along with our cost coming well under the cap. And because We pitched Calypso as New Horizons with magnetometer on the side. We considered it to be a relatively low-risk mission architecture. Thanks, New Horizons, for that. I'm going to flip through the science really. Oh, it just played magically. I love it. I love it when a plan comes together. So when we talk about a diversity of ocean worlds, we have everything here from Earth all the way to Pluto on this particular slide when we're talking about known and probable ocean worlds. But there's a lot of really exciting questions left to be answered in the Uranian system, including how did we get all those moons and why are they all on their side? And so I think we have a lot to understand about whether or not there's something really special about the Uranian system. Spoiler alert, I'm pretty sure there's something really exciting about the Uranian system, but trying to understand moons that form in these giant impact scenarios as opposed to something that's forming in situ. So there's some really compelling science to be done, and certainly we think there's a lot of great geologic evidence for Ariel being an ocean world, including our flat floored troughs and our relaxed craters, and I'm sorry, I'm going very fast because I'm running out of time, including this really great work that Julie Castillo-Roget published a couple years ago talking about the kinds of oceans we might find in Ariel. And the summary here is that there might be a really conductive thin ocean or a really conductive muddy ocean. And with the magnetometer that was spec'd with Calypso, we pitched that we actually thought we could detect an ocean if it was of one of those two varieties in a single flyby. But we also thought that a negative detection would be robust. If you want more details on that, I really would recommend you go look at Ben Weiss's paper, but I know that there's been some other really great papers that have come out in the last couple of years about single flyby detections of oceans in the ice giant systems that I recommend you go look at. This slide I always think is really exciting because it kind of shows you how complementary the coverage of the cameras is on all 5 of the Uranian moons with respect to what Voyager acquired during its single flyby. So while we don't have absolute total global coverage, I think we get enough coverage here at good enough resolutions that we're going to really be able to solve some of the problems that we've been having for a long time about what's going on with all of these really unique moons. And I don't want to discount the fact that we have a lot of other moon and ring science that can be done. But I have 5.5 minutes left. So I'm not a KBO person. This isn't the part in the presentation where Bill Botke stands up and tells you all of the really exciting, amazing things that can happen with KBO science and small body science. So I'm going to read these because I think they're also very exciting, but this isn't my vocabulary. The Kuiper Belt is really the place to be studying for understanding planetary systems, how they're born, how they evolve, how do planets evolve, all that really awesome stuff. And Kuiper Belt objects have witnessed firsthand the early history of the outer solar system, and this is a really important place for us to be spending our energy in terms of understanding and solving big problems in planetary science. I mentioned that we had targeted a dwarf planet binary KBO called Gungundima, and it has this small little red companion Greku. I have another slide that's like this. And I think studying a binary like this is actually really interesting because you can ask questions about whether or not binaries like this are going to form through accretionary processes or whether or not we have something special going on in this particular system, maybe some kind of collision forming this binary rather than accreting. But the bottom line is that this system provides us with a preserved record of what happened to the primordial Kuiper Belt during Neptune's migration through it. This then sort of begs the question whether or not you believe our argument here that large KBOs might also be ocean worlds. We have a couple really interesting candidate bodies here that suggest that maybe these kinds of bodies either had liquid water oceans or may have liquid water oceans, and I think a mission like this can really help solve some of those problems. So as a baseline, this mission concept was really relying heavily on the Jupiter Gravity Assist, and you can launch it on a really big rocket, and that's how we do this much science at 2 different planetary bodies in less than 20 years. But what's really exciting to me about this is that even if you lose that Jupiter encounter, you can still do this mission and launch in just about any year you want between now and forever. Okay, that's probably not true, but it really depends on which ocean world, whether it's Miranda or Ariel that you're really interested in, and which dwarf planet. You can also do this with Triton, and I'm sure somebody has a question about Eris. The answer is yes. The longer answer is it depends on what your appetite is for longer missions and how big of a rocket you can get. But the bottom line is that this is a mission concept where there's a lot of really viable architectures, or I should say trajectories, that can get you some really exciting science depending on what your particular interests are. So it's a very cool concept. And I just said this, but this is with a different table. This is a very flexible architecture. And as I mentioned before, you could do this at Triton. It's a little bit harder at Triton because Triton's so much further away from Neptune, so you don't get quite the same kick, which really changes which dwarf planet you can go to. But again, that depends on whether or not you want to do that KBO flyby in your primary mission and whether or not you want to actually select that KBO for scientific reasons, or if it's something that you're willing to be opportunistic about. I should say that we really focused on KBOs that were greater than 600 kilometers. I don't need to spend too much time here because this is literally a picture of New Horizons with a magnetometer on the side of it. And so trust me, we really hung our hat on the low risk heritage of a successful New Horizons spacecraft. But I do want to point out that we really kept things, as far as we were concerned, under that sort of New Frontiers cost cap that we were given. Although certainly if you start including things like phase E and F, you do creep up a little bit, but that's not a surprise when you're talking about 20-year-long missions. And I think there's some really great conversations we might have later about how you actually handle long missions. I think as Paul was talking a little bit about the Trident mission, I think it's really, somebody said to Candy Hansen once, why are you putting all this work into a mission that, you're going to be retired by this thing happens? And she says, I'm going to earn my rocking chair. And I think that's a really cool way to think about how, a lot of us sort of feel a bit of a responsibility for getting these missions new starts and actually make them happen, even if it means that we're not the ones at the forefront when everything is coming down back to Earth. And so why now? I mean, I think the Uranus system, I think the Kuiper Belt, and I think ice giant systems are really some of the last frontiers that we have in our solar system that really need to be discovered, but they are also some of the places that really hold the answers to some really key questions that we have about how we understand our solar system, and then by proxy, how we understand other solar systems. So I'm sure I skipped things. Hopefully that means you have questions.
Thank you for that really also rapid fire, but very informative overview of
I think
the
that was a
Calypso
25-minute
concept.
presentation between two people in 11, 12 minutes.
And you had 30 seconds or a minute left over, so you did good.
All right. A quick question if there's, oh,
Go ahead.
thanks, Simon. Does this use the hibernation architecture, mission architecture?
That's a really good question that I'm going to tell you to email me, and I will send you the report if we can't find it online, because I don't know the answer to that.
So you mentioned you can sort of trade off between Miranda and Ariel. So what if you launched two of them?
Even better.
Could you, if you were to launch, like, do a single launch that just was a bigger rocket, so you had two of them on there, could you, would a single launch opportunity allow you to do both?
Both Miranda and Ariel?
Yeah.
I mean, I don't see why not. I think you have to ask the question, is Miranda really your favorite target, given most everything we're hearing is that Miranda probably doesn't have an ocean anymore. So the question I'm going to throw back at you, philosophically, would you rather two opportunities to detect an ocean at Ariel for confirmation?
Or you do one to Triton and one to...
Or do you do one to Triton? I mean, this goes back to that concept that Amy and Alan did back in the 2018, 2019, where there was a kind of a mini Uranus orbiter and probe, and then there was a Triton flyby that would go on. Maybe I'm getting it reversed. It was a Neptune mini orbiter, and then it was a Uranian moon flyby onto a KBO, so essentially Calypso. So it was those two spacecraft kind of heading out to the ice giant system. So one kind of doing orbiter science and one doing flyby science so that you could get into the Kuiper Belt. And that might be the more convincing, is to say, how about we attach Calypso and Ocean World Surveyor onto one rocket?
Yeah. Okay, so but there isn't, yes, anything that is particularly timing wise about anything. It's kind of open. Is what I'm getting.
Yeah, I think the things that are your constraint are, how big of a rocket can you get? Can you use the Jupiter gravity assist? And what is your appetite or your tolerance for mission length, right? I think you can make
anything we're going to talk about this afternoon. Yeah.
Exactly. I think, there was a lot of folks who were like, oh my God, what do you mean we could do Triton and Eris? there's complications with that, right? Is it worth it? I don't know, maybe, probably, but I think they're all worth it. It's just a matter of what is the best, what is the thing that you can bring the community along with you with the most enthusiasm? And I think there's a lot of variety here, which is both good and also a little overwhelming.
Cool.
Okay, let's thank Emily again.